Hi everyone, we're going to start lesson 4.4. If you haven't printed out the handout yet, you need to do that now so that you can fill in your sheet along with me as I go through the examples. So these suggestions that you see here are all important. When you start doing your homework, you need to come back and read these, and they will help you remember the steps and remember important things. You know, follow the order of operations is a big one, and reading the question. So let's do our learn the laws. Yes, if you don't remember the laws from grade 9, you have to memorize them now. You have to learn them now. Write this as a single power with a positive exponent. Okay. Here's our solution. First, we have to use the power of a power law. So the power of a power law is the one that takes care of the two exponents when they're like that. When you have an outer exponent outside of a bracket, you have to distribute it into the bracket. You're kind of putting in backwards. So these two have to be multiplied together. That's the power of a power law. And these two will have to be multiplied together. So that gives us these values here. Next thing we're going to do is simplify the numerator. Remember, we're following the order of operations. So this operation, like it's like a division operation here, it separates the whole numerator from the denominator. So I have to simplify the numerator first before I can move on to the denominator. So that's just with my product law where I added the two exponents that were in the numerator. Now I'm going to use the quotient law, so I have to subtract these exponents here. I get n to the power of negative 10. But I've got to look at my instructions, and they do say I have to write them as a single power. We did that, single power, but with a positive exponent. Okay, positive exponent. Right now I've got a negative exponent here. This is negative 10. So I'm going to write it with a positive exponent, and that gives me 1 over m to the positive 10. Or you could write it like this. They're the same thing, but when you have a 10 to the power, 1 to the power of 10, you're going to get a 1 again anyway, so you get back to this spot here. That's your first example. So it's a good idea, if you want to pause it now, do the example again or slow down the pace, do pieces of it over, make your own notes as you need to, and then go on to the next example. Example 2, express your answers in rational form with positive exponents. So there's two ways to do a question like this. Number one is we can substitute in right away because we have a equals 2 and b equals negative 1. We can substitute in right away. Or number two is we can simplify and then substitute. So we're gonna do it that way. We're gonna clean this whole thing up first, and then we'll substitute in for a and b. One thing I want to point out here is we've got two different forms. We've got a radical or square root form, and we've got exponential. So this radical here, I'm trying to highlight it here, this huge radical sign or square root sign in this case, we don't want that. We don't want a square root symbol and exponents. Those are two different forms. We want to use the same form for both. So I need to convert that to exponential form. And that's what the 1/2 is here. So the 1/2, if you remember, is the same as the power of 1/2 is the same as the square root. So I'm going to use exponential form rather than radical form because it's easier to work with everything that way. Inner first. So we have to do the inner brackets first. We have to clean all this mess up first before we can deal with that outer one. So the first law we have to work with is power of a power. This 9b cubed, this term is okay. I can't do anything with that. But this term right here, this piece, ab squared, I'm going to need to take that power of 2 and I'm going to have to apply it to the a. And I'm going to have to take that power of 2 and apply it to the b. That's what the power of the power law is. Same thing with the 3 down here. It's an outer power. It's a separate power. It doesn't have its own separate base. It has this as a base. So the power of 3 has to be applied to a squared and to b cubed. Power of a power law is multiplication. So when we multiply those exponents in, we get this line here. That's the power of a power law. Now we can work on the numerator. Okay? Now we can work on getting the numerator simplified. With the product law, we just multiply all the numerator parts together, and we get 9a squared b to the power of 5. Our denominator hasn't changed. that one is still the same. Okay, so running out of room here, we're going to have to move up. Step 4 is bedmass. That means we're following the order of operations. The order of operations is I have to do what's inside the bracket first down here. I'm highlighting it. Inside the bracket first, I have to take care of all this stuff before I can deal with the power of 1/2. So using my exponent laws, it simplifies nicely here. Now I can finally take care of this piece. The outer exponent gets distributed in, so the outer exponent gets applied to the 9 first of all. So 9 to the power of 1/2 is the first thing I have to do. 9 to the power of 1/2 is the same thing as saying the square root of 9. Then I have to apply to the a. So a to the power of 4 to the power of 1/2. So I'm going to multiply the -4 by the -1/2. Then b to the power of -4, b to the power of -4 to the power of -1/2. So the power of -1/2 gets kind of distributed backwards into that bracket. And we have this, but I have to take a look at my instructions again, and it said I have to use positive exponents. So that's positive exponents. The other part of the instruction says express your answers in rational form. So this is a rational now because we've gotten rid of the negative exponents. It's written as a fraction. Rational means fraction. The other thing we were supposed to do, if you remember, is substitute for a and b. So always substitute using brackets. I substitute in there with my brackets, a and b, and then just clean it up, and we get 3/4. Again, slow it down, pause the recording, go back and do it again, try it yourself, see if you can do the whole thing yourself, make sure you understand the steps. Example 3 is to simplify. Again, we've got that radical symbol in there, which would be better if we just had exponents instead of radicals. So can you think of what way we could write the square root of 6 without using the square root? Look at the steps from the previous examples if you need to, but by now we should be getting better at understanding the process and knowing what to do next. So I don't want you memorizing a bunch of steps. I want you understanding how to tackle a problem like this. What do I do first, right? So the first thing that I notice is that's that radical sign. So I'm going to change that from a radical sign to a power of 1/2. It has to have a big bracket all around everything that the radical sign was over. Also has to have the power of 1/6. So it's 1/2. So my next step, I had the 1/6. It's got to stay on the outside, and the 1/4. These two have to stay out, right? I'm not ready to do them yet. I have to work with the inner bracket first. This power of 2 goes on to the 8. 8 squared, 64. Power of 2 gets applied to the x, becomes x to the power of 12. The denominator didn't change, so that stayed where it was. The next step I'm going to do is take care of those outer exponents. So the 1/6 now comes in. So I'm going to do the 6th root of 64. So how did I get a 2 out of that, right? How did I know that was 2? Those are good ones for you to memorize. Are the I'm going to try to erase that. That's messy. Those are good ones for you to memorize. Are the 2 powers of 2, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. Those, they come up a lot, so that when you get something like 64, you recognize it as 2 to the power of 6. So it's the 6th root of 64. Then we multiply 12 by 1. 12 and the 1/6 get multiplied together here. That gives us this 2. And the exponent here of 1/4. So I have to do 625 to the power of 1/4. So that's the 4th root of 625. And that's a common one that comes up a lot also. That's 5. Right? 5 to the power of 4 is 625. Then 8 times 1/4 gives me this 2 right here. Next step is to clean that up a little bit into 2/5. All right, let's keep moving. Example 4, simplify. So the first thing I noticed about this question is that it has a base of b everywhere. All of them have a base of b. So these two are being multiplied together, so that's going to be the product law, which means I'm going to be able to add their exponents. These two have division between them, so they'll be subtractions. That's quotient law. However, the first thing, okay, sorry, you can't see what I'm doing here. When I say the first these two, I'm saying these right here, that's invisible multiplication. So I'm going to be multiplying those two, meaning their exponents are going to add together. This division means that when I get there, I'll be subtracting those exponents. But first, the power of a power law needs to be applied first before we can do the other laws. So power of a power law, that takes care of this 3 to the power of, b to the power of 3 to the power of m and b to the power of n to the power of 2. We multiply them together, right? And that's how we get these exponents here. So we took care of the power law. Now I can work with my other laws. I'm going to write my base once. I had a base of b for all of these. Since I'm multiplying and dividing, I can use the power laws. I only write the b once here, and then I collect all of my exponents using the power laws. So it is collecting like terms. I get b to the power of 0, which is 1. Example 5, different type of question we're doing. Here's our last example. Solve for x. Bases must match. When I look at this question, I see the bases already match. So I should be able to kind of look at that. The bases already match, so we only need to look at the exponents to deduce what x must be. So I should kind of be able to figure out what do I need to sub in there for x so that I would get a 5, right? I should be able to kind of do that one in my head and know what x must be. But what we can do, because our bases match, is we can just kind of ignore them and just rewrite the part that I circled in red there as a mini equation. X minus 4 equals 5. Now I can solve that and get x equals 9. Next one's a little harder. Solve for x. Again, bases must match. It's easier if we don't have to deal with fractions for this question. So that 1 over 64, let's get it out of fractional form and make it 64 to the power of negative 1. Our bases have to match, right? They don't match right now. What you do is you always look at the lower number of the two. So we've got a 2 and a 64 in our bases. Can we write can I rewrite the 64 as 2 to the power of something? So is 2 to the power of anything 64? So I'm trying to think if instead of having a 64 here, I could write it as 2 to the power of something. The negative 1, that's still there, right? That didn't go anywhere. But I'm just trying to change this because it says up here our bases must match. So I'm going to have to make my bases match. So 2 to the power of 6 is 64. So that means instead of writing 64, I'm going to write 2 to the power of 6. It's exactly the same thing. Using my power of a power law, I multiply those two numbers together, and I can see now easily that x is 6. Last one. Again, same instructions, solve for x, bases must match. Our bases must match. Always look at the lower number of the two numbers that you're dealing with. Can you rewrite the larger one? That's the 8. Can I write 8 with a base of 4, right? Is 4 to the power of something 8? No, 4 squared is not 8. 4 squared is 16, so I can't do that. So we're going to have to go even lower. We go lower than 4, and we're going to look at a base of 2. Can I rewrite both of these, 4 and 8, with a base of 2? Because I can't use a base of 4. So is there a way to take 4 and rewrite it with a base of 2? And is there a way to write 8 and rewrite it with a base of 2? Yes, there is. 2 to the power of 2 is 4. 2 to the power of 3 is 8. So I put those in there. Then I have to use my very powerful power of a power law here and multiply these together. So don't forget the 2, it has to be multiplied into all parts here. And I'm going to multiply these two together, power of a power law. So my bases match. I've got my exponents tidied up. I can now ignore my bases. Ignoring the bases does not mean I'm dividing everything by 2 to get rid of them. They're still there. I'm just ignoring them for a minute so that I can figure out what x is, so I can solve for x. So I'm looking at my exponents here. 2x plus 2 equals 9x. That's a nice little linear equation I can solve, and I get x equals 2 over 7. So for your homework, you've got some questions to do from your textbook. Also, your textbook doesn't have great questions like example 5. They don't have enough good practice for you, so there's another handout for you. You don't have to print it out. You can just, when you're doing your homework, you can just look at the handout and just write down question 9 on the same page you're doing all your other homework on and do those questions. Remember that there are solutions, a lot of solutions to questions on D2L, so when you're getting stuck on your homework, take a look on D2L. Good luck!